Have you ever wondered how that intricate model of the Eiffel Tower sitting on your desk was made? Yes, you guessed right. It's the magic of 3D printing. These remarkable machines, known as 3D printers, have revolutionized the way we create and conceive objects. From intricate architectural models to life-saving medical equipment, their versatility is astounding. They bring the power of creation into our homes and offices, transforming digital designs into tangible reality. But how did 3D printers come into existence? Let's dive into the history. The journey of 3D printing began in the 1980s. Yes, you heard it right. The genesis of this revolutionary technology dates back to the 80s. It all started with a man named Chuck Hull. A forward-thinking inventor, Chuck, in the year 1984, invented a process he called stereolithography. This was the birth of 3D printing as we know it. Stereolithography, or SLA, was a groundbreaking technique that allowed the creation of 3D objects layer by layer using a UV laser to solidify photopolymer, a type of liquid plastic. This was the first time in history that a physical object could be created from a digital design. Fast forward to 1988, when Chuck Hull co-founded 3D Systems, a company that commercialized SLA technology. The first commercial 3D printer, known as the SLA-1, hit the market. It was an impressive piece of tech, but it was just the beginning. The 90s saw further advancements in 3D printing. A significant milestone was the creation of the first 3D printed part, a feat accomplished by Stratasys in 1992. This was followed by the development of other 3D printing technologies like fused deposition modeling and selective laser sintering. The new millennium brought with it even more revolutionary changes. In the year 2000, a company named Organovo developed the first 3D printed organ, a functional kidney. This was a game-changing moment, showcasing the potential of 3D printing in the medical field. The rise of commercial 3D printers came into full swing in the early 2000s. Companies like MakerBot and Ultimaker started to produce affordable, desktop-sized 3D printers, making the technology accessible to hobbyists and small businesses. Over the decades, 3D printing has evolved dramatically. From its humble beginnings in the 80s, it has grown into a multi-billion-dollar industry. It's an integral part of various sectors, from manufacturing and aerospace to healthcare and education. Today we can print everything from toys and tools to houses and even human organs. Over the decades, 3D printing has evolved dramatically, and today it's an integral part of various industries. From a concept in a lab to a tool on our desks, 3D printers have come a long way. The evolution of 3D printers has been nothing short of a technological roller coaster ride. Born in the 80s, the first 3D printers were hulking, expensive beasts, available only to a select few. They were primarily used for rapid prototyping, a process that allowed engineers to create a physical model of their designs quickly and cheaply. However, as with all technology, 3D printers began to evolve. The 90s saw the development of new 3D printing techniques such as stereolithography and selective laser sintering. These methods allowed for the creation of more complex and detailed objects, opening up new possibilities for the technology. The turn of the millennium marked a significant shift in the 3D printing landscape. 3D printers became smaller, more efficient, and crucially, more affordable. This shift was largely driven by the expiration of key patents, which allowed new companies to enter the market and drive innovation. The next big leap came in the form of desktop 3D printers. Compact, user-friendly, and reasonably priced, these machines brought 3D printing into the homes and offices of everyday people. No longer constrained to industrial applications, 3D printers were now being used for everything from creating custom jewelry to printing replacement parts for household appliances. Today, 3D printers are more versatile and accessible than ever. They can print in a wide range of materials, from plastics and metals to ceramics and even human tissue. They're used in industries as diverse as fashion, architecture, and medicine, and they're becoming an increasingly common sight in schools and homes. The evolution of 3D printers hasn't just changed the machines themselves, but also the way we think about manufacturing. These devices have democratized the production process, allowing anyone with a 3D printer to turn their ideas into tangible objects. The evolution of 3D printers has revolutionized the way we create and manufacture. Just like the diversity of objects they can create, 3D printers themselves come in various types and sizes. It's quite fascinating how one technology can have such a wide array of variations, each with its unique features and uses. Let's start with the most common type, the FDM, or fused deposition modeling printers. These machines work by heating and extruding a plastic filament layer by layer until the object is fully formed. They are great for beginners and hobbyists, providing a cost-effective way to create simple and sturdy models. Next on the list we have the SLA, or stereolithography printers. These work quite differently. Instead of melting plastic, they use a UV light to harden a liquid resin, creating highly detailed and smooth objects. This makes them perfect for intricate designs such as jewelry or dental models. Now let's talk about SLS, or selective laser sintering printers. These machines use a high-power laser to fuse small particles of plastic, metal, ceramic, or glass powders into a mass that has the desired three-dimensional shape. The high precision and strength of SLS printed objects make them suitable for functional prototypes and end-use parts. Then we have DLP, or digital light processing printers. Similar to SLA printers, DLP printers use light to solidify a liquid resin. However, DLP printers use a digital light projector screen to flash a single image of each layer all at once, allowing for faster printing times. This makes them ideal for rapid prototyping. Finally, there's the binder jetting and material jetting 3D printers. Binder jetting printers create objects by selectively depositing a liquid binding agent to join powder particles layer by layer. Material jetting printers, on the other hand, deposit droplets of build material onto the build platform, hardening them with UV light. These two types are often used in industrial applications for their ability to create full-color models and parts with multiple materials. Each type of 3D printer has its strengths and weaknesses, making them suitable for different applications. So whether you're a hobbyist looking to bring your ideas to life, or a professional needing high-precision parts, there's a 3D printer out there for you. So how do you decide which 3D printer is the right one for you? Well, there are several factors to consider. Let's break it down. First, think about your budget. The price range of 3D printers can vary wildly, from a few hundred to several $1,000s. You don't necessarily need the most expensive machine to get great results. There are many affordable options that offer excellent print quality. So, set a budget that you're comfortable with, and start from there. Next, consider the purpose of use. Are you a hobbyist, looking to print small figurines or household items? Or maybe you're a professional needing to create detailed prototypes for product design. The scale of your projects and the level of detail required can influence the type of 3D printer you need. Now let's talk about material compatibility. Different 3D printers support different materials. Some printers work with a wide range of materials, from basic plastics like PLA and ABS to advanced materials like nylon, wood, and even metal. Others might only support a single type of material, so it's crucial to consider what materials you plan to use for your prints. Ease of use is another essential factor. Some 3D printers are plug-and-play, requiring minimal setup and calibration, making them suitable for beginners. Others offer more customization and control, but may require a steeper learning curve. If you're new to 3D printing, you might want to start with a user-friendly model and work your way up. Lastly, don't forget to check out online reviews and community forums. They can provide valuable insights into a printer's performance and reliability, and can also offer troubleshooting advice if you run into any problems. Remember, the best 3D printer is the one that fits your specific needs and budget. So take your time, do your research, and happy printing. The journey of 3D printing is far from over. In fact, it's just getting started. As we gaze into the crystal ball of technological advancement, the potential future of 3D printing unfolds in myriad ways. Imagine a world where medical professionals can print functional organs on demand, eliminating the need for organ donors. This could be a reality sooner than we think, with researchers already making strides in bioprinting. Personalized medicine can be taken to a whole new level, where doctors can print customized pills, tailored to a patient's needs. Or consider the construction industry. The idea of printing entire buildings might sound like science fiction, but it's happening. 3D printed homes and offices are already a reality in some parts of the world, offering cost-effective and sustainable solutions. Picture yourself in a kitchen, where food printers can create gourmet meals at the touch of a button. From intricate chocolate sculptures to nutritious, customized meals, the culinary world can be revolutionized by 3D printing. The possibilities are endless, limited only by our imagination. As technology continues to evolve, 3D printing could become as common as using a microwave or a mobile phone, It holds the potential to transform industries, redefine manufacturing, and change the way we live. As we continue to push the boundaries of what's possible, who knows what the future of 3D printing holds?